Hey, fifth graders. This is Miss Richardson. I hope everyone had a wonderful fall break. Your first term of the year is done, so we're 25% finished with the school year. Can you guys believe it? And so you guys are starting fresh in Unit 2. So we are starting off by talking about ratios. The standards we were covering are right here, our learning targets. You can see on the screen there. All right, so what is a ratio? A ratio compares two amounts or values. So, for example, if you are talking about how fast you're riding in your car, you're going to talk about miles per hour, how fast you are traveling miles per hour. So, if I go 120 miles in 2 hours, that's a ratio because I'm saying 120 miles compared to 2 hours, okay? That's a ratio. Now, there's three different ways we can write ratios. We can write ratios with, I thought I didn't start recording, but I think I did. All right, so we can write ratios with a fraction. So if I was saying 120 miles for every 2 hours, right? So I can write my ratio that looks like a fraction. I can use a colon, 120 miles for every 2 hours, or I can write with the word to, 120 miles to 2 hours. So all three ways, and there's another example here. There's three different ways to write a ratio. All right, so if you want to watch this awesome video, that's 7.5 minutes about writing ratios. If you're doing your work and you need a little more help, then come back and watch this video. It is here in the slide deck for you. All right, so we were recently working with fractions, so ratios can be treated a lot like fractions. And in fact, when you simplify a fraction, that's exactly the same way you simplify a ratio. So here, you could either look at this as a fraction or a ratio, 6 to 8. Just like with a fraction, we would divide 6 and 8 by their greatest common factor, which is 2. So when I divide 6 by 2, I get 3, and 8 divided by 2 is 4. So the fraction and the ratio in simplest form is 3 to 2. I'm sorry, 3 to 4. Even if my ratio is written with a colon, I'm still going to use the greatest common factor in order to simplify numbers, or ratios, I should say. So we would think of this, what is the greatest common factor of 20 and 28? So that would be 4, right? So 20 divided by 4 is 5, and 28 divided by 4 is 7. So 20 to 28 simplified would be 5 to 7. All right, so you guys pause the video and try simplifying these three ratios and then come back and see how you did. All right, on the first one, I hope you divided both of these numbers by 3. So simplified, this ratio is 3 to 2. What about the second one? What can you divide 25 and 5 by? By 5. So 25 divided by 5 is 5. 5 divided by 5 is 1. And then did you guys figure out that 12 is the least common multiple? No. Greatest common factor, 12 divided by 12 is 1, and 36 divided by 12 is 3. So I hope you guys got the same answers I got. Now let me know if I make a mistake. I do that a lot, not on purpose, but we all make mistakes, right? All right, so you can also create equivalent ratio. Well, so if you take a ratio and simplify it, the unsimplified and the simplified ratios are equivalent, but the numbers don't always have to get smaller to create equivalent ratios. Sometimes the numbers will get bigger. So for example, we start out with the ratio 6 to 7. I can create an equivalent ratio by multiplying 6 and 7 both by 2. And if I do that, I get 12 to 14. I could go back to the original numbers and multiply them both by 3. Then I would get 18 to 21. And also 6 to 7 is equivalent to 24 to 28. okay, as long as you divide both numbers by the same digit. Well, if we start out with 48 to 36, we could divide both of those numbers by 2. So an equivalent ratio would be 24 to 18. If we divide both of these numbers by 3, we could create the equivalent ratio of 16 to 12. So on and so forth. If we divide them both by 4, we'd get 12 to 9. All right, so I want you guys to pause the video, and I want you to start out with 2 to 7, and I want you to see if you can create 4 equivalent ratios. All right, so there's no limit to how many we can create, right? So probably we start with a small number and we do times 2, so we get 4 to 14. If we divide them both by 3, we get 6 to 21. We could divide them both by 5 and get 10 to 35. We could even divide, multiply, am I saying divide? I hope I'm saying multiply. We could even multiply both of them by 10 or 100. We could get 20 to 70. So there's no limit to how many equivalent ratios we could create. All right, moving on, guys, moving on. Now, when you do create equivalent ratios, when you look at the word problem, the order of the words have to match the order of the numbers, okay? So for example, let's look at this situation right here. The ratio of boys to girls in a class is 2 to 3. So since the word boys comes first and the number 2 comes first, 2 belongs to the boys and 3 belongs to the girls. So you can't flip the order, okay? So if there are 18 girls, how many boys are in the class? So basically they made a chart like on the previous slide where they continue to multiply 2 and 3 by the same digit until they got the number of girls up to 18. So basically what that looks like is we started off with 2 boys to every 3 girls. 18 girls, since the girls are on the bottom of the first ratio, we got to put 18 on the bottom of the second ratio. So what would we multiply 3 by to get to 18? We'd multiply by 6, right? Well, we're going to do the top to the number of boys. So if we multiply 6 times 2, if there's 18 girls, this tells us that there are 12 boys. That's the answer. There's 12 boys in the class. All right, let's start it. Let's try it right here. The ratio of apples is 4 to pears. Pears is second, so it's 1. So they said, what if there's 16 apples? So we want the top number to be 16. Well, if we multiply both of these numbers by 2, we get 8 to 2. What about 3? If we multiply by 3, we're going to get 12 to 3. What if we multiply them both by 4 times 4? So 16, that's what we were looking for, right? 16 apples. So 1 times 4 is 4. So the answer is 4. And you could keep going. This is just a simpler way to do it, just a shorter way, I suppose. All right. How you feeling? You got it, dude? I bet you do. I bet you do. All right, so like I said, guys, the order of the words matter. So, or in this situation, there's some shapes. So here we want to know, what is the ratio of blue circles to total shapes? Well, we're going to count the total number of blue circles first. 1, 2, 3, 4, 5, 6 blue. 6 blue circles. And then how many total shapes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 6 to 18. And then it says simplify if possible. So if we could divide both of those by 6, you guys, we get 1 to 3. All right, I'm going to be working on these, and I want you guys to pause the video, and I want you to try all of these on your own, and then come back to the video and see if we agree with each other, okay? All right, the next one we have 1, 2, 3, 4. 4 to 18. Can we divide 4 and 18 by the same number? We can, by 2. 2 to 9. Did you guys get 2 to 9? The next one is squares. 1, 2, 3, 4, 5. 2, 6, 5 to 6. That cannot be simplified. The next one, the total number of shapes, comes first to triangles. We know there's 4 triangles, so we can simplify that to 9 to 2. There are 6 blue circles. 6 blue circles. 2, how many hearts? 1, 2, 3. So that can be simplified as 2 to 1, right? And then green squares, 1, 2, 3, 4, 5. 2, 1, 2, 3, and that cannot be simplified. I hope I got all those right. I was trying to do them kind of quickly. So let me know. Did I miss one? All right, then it says write 3 equivalent ratios. So like I said, guys, there's no limit to how many of these we can create. So I'm not going to take the time to do that, but as long as you took your original numbers and you multiplied all of them by the same digit, both the top and bottom, then you did create equivalent ratios. And I have total faith that all of you did that very, very well. All right, so one of the things you're going to have to do is determine whether ratios are equivalent. Well, there's 2 different ways to do this. One way is to simplify both ratios down to the simplest form and see if they match. For example, if I divide 4 and 6 both by 2, I get 2 to 3. And then if I divide 12 and 18 by 6, I also get 2 to 3. So are these equivalent? Yes, they are, because I can simplify them all the way down. Well, sometimes the numbers get too big, or sometimes it's weird, like there's a decimal in here. So there's a different way to check to see if ratios are equivalent as well, and that's by cross multiplying. So you're going to cross multiply, and if those products are the same, that means the ratios are equivalent. For example, if I multiply 18 times 4, I get 72. And if I multiply 12 times 6, I also get 72, which tells me these ratios are equal. All right, so even on the second one with a weird decimal in there, we can cross multiply 8 times 7.5, and I get 60. And then 20 times 3 is also 60. So yes, these are also equivalent. All right, so you guys pause the video and see if the rest of them are equivalent or not. All right, did you guys use cross products? So 15 times 6 is 90, and 12 times 7 is 84. So are these equivalent? No, they are not. What about the next one? You guys are probably faster than me. 35 times 36 is 1,260. And what about 28 times 45? Same thing. So are these equivalent? Yes. Yes, they are. And 32 times 26 is 832. And then what about 72 times 12? Oh, close, but nope. This is a no. These are not equivalent. Okay, so you'll be doing those. You'll be doing problems similar to those. All right, so different ways of showing equivalent ratios. Here we have a model of showing what 2 to 3 looks like. So if we have 2 blue cubes to every 3 cubes, that means we have to have a total of 5 cubes, right? Here's another model of 5 to 7, what that looks like. And you can create ratio models when you're doing problems like this down here, the baseballs and soccer balls. All right. This kind of looks a little bit like those, the charts we were filling out to create equivalent ratios. All right, so here's one that says if the ratio of baseballs, which is 4 to soccer balls 7, 4 to 7, and there are 16 baseballs. So which one is baseballs, 4 or 7? Baseball's the first number, so 16 must go on the top. The question is, how many soccer balls are there? Well, what do we do? How do we get from 4 to 16? We multiply by 4. And then if we do that on the bottom, 7 times 4 is 28. So the answer to the question is 28 soccer balls. All right, you can also use a double line graph. If you start with 20 to 1, you can create equivalent ratios. You can half that. Well, half of 20 is 10 and half of 1 is 1/2. So an equivalent ratio would be 10 to 1/2. You can half 10 and 1/2, and an equivalent ratio would be 5 to 1/4, right? You can keep halving. Or you can double 20 and 1 and get 40 over 2, 40 to 2. And then you can increase 40 by 20 and get 60 over 3. So there's a lot of different ways to show and model equivalent ratios. Here's a video. If you're a little confused on that and you need to watch this video, then come back to the slide deck and do that. You can also use a coordinate plane, or you can graph. So if our ratio of number of batches of cookies to cups of chips is 1 to 2, so we have batches to cups. So we have batches of cookies to cups of chocolate chips. We can create all these different equivalent ratios, 2 to 4, 3 to 6, and then we could create ordered pairs from those numbers, 6 to 12, and we can put those on a coordinate graph, right? And we're going to graph a little later in the year, but this is just a good introduction. So to show on the graph, on our x-axis, our horizontal axis is the number of batches, and then our y-axis is the cups of chocolate chips. If we graph these coordinates, this tells us what to do on the coordinate graph. This one tells us we don't go right or left, and we don't go up. So we put a dot at 0, 0. This one tells us from the origin to go right 1 up 2. So go right 1 up 2. There's a dot. This one tells us to from the origin go right 2 up 4. So right 2 up 4. This one tells us to go right 3 up 6. And so that's where all these dots came from on our coordinate plane. And then when we draw a straight line, that also confirms that our ratios are equivalent, because it tells us that our information is linear. Nothing changed. No number had a different rate of change than the previous number. Okay? That's a little complicated, but we'll get there, you guys. We'll get there. All right, so what if you had to graph on a coordinate plane? Once again, here's our coordinate plane. The first number tells us how to go right, how many spaces to go right, and the second number tells us how many spaces to go up. So the first number tells us you always start at the origin. You go right 2 spaces up 3. And down here, these are all equivalent ratios. It says if Sam can bike 4 miles, so here's 4 on our miles section, in 2 hours, how many miles can he bike in 3 hours? So basically we would just create, sorry, I didn't mean to change the slide. We would create equivalent ratios, and then we could take those ratios, create coordinates from them, x, y. We could take a graph, and we can graph each of these numbers. So 0, 0. The second one is 1, 2. From the origin, go right 1 up 2. From the origin, go right 2, then up 4, right 2 up 4, make a dot. From the origin, go right 3 up 6. And that's why there's a line through this little section right here. Okay, and that's one way we're going to graph equivalent ratios. All right, here's a good ratio on coordinate plane activity, or not activity, but a good video that you can look a little bit more about graphing on a coordinate plane. We will be practicing that a little more later in the school year. Okay, here's another example of that. I want you to pause the video, read the scenario, look at the graph, look at the table and the graph of the information that you find here. All right, and then the very last section is talking about finding missing numbers. So you can go to LaunchPoint and then click on this picture to watch this BrainPop video. But one thing I just wanted to go over with you, the last thing I wanted to tell you was sometimes it's easy to figure out how we get from 4 to 36, or from one number to the other. So 4 goes into 36 9 times. So it'd be easy to figure out that the missing number here is 27. However, sometimes one number does not go into the other number a whole number of times, right? 6 is not a factor of 21. So one way you can always figure out a missing value is to cross multiply like we did earlier. Okay, so if we multiply 28 times 6, I'm using my calculator, 28 times 6, I get 168. And then if I cross multiply this way, I get 21 times x. 21 times x is 21x. In order to solve for my missing value, I am going to divide both sides by 21. Okay, that's the way to figure out what x is. You cross multiply, and whatever is attached to that variable x is what you divide both sides by. So 168 divided by 21 is 8. So this missing number is 8. X is equal to 8. Okay, this is going to come back later on in the year, and we'll spend more time on it. But for now, I just wanted to introduce that to you. So most of these are going to have a whole number that you multiply by, but I want you guys to practice solving for the unknown number this way as well. So cross multiplying, I should say. So 36 times 2 is 72. 24 times x is 24x. You just push those together. And then to solve for x, you divide by whatever the number is attached to the x. All right, so what is 72 divided by 24? 3. All right, I want you guys just to practice this. You're not going to have questions right now over this skill, but I did want you to introduce it to you, and I want you guys to practice those. So practice those, and then you'll be ready to answer your questions this week. We'll leave this for later on, the Let's Practice section, but if you want to go ahead and set those up and try to answer them, that would make me so, so happy. And if you would send me the answers, I would be thrilled, you guys, so thrilled. All right, guys, so good to be able to communicate with you, even though you're not communicating back with me, but you can always send me a message on Canvas inbox. Everybody have a great day, and I will check with you guys later.